Alright, this is the first video for Unit 2. We're going to be looking at properties of matter in this first concept A. My students should be able to differentiate between physical and chemical properties. By the end of our video and lesson in class, you should be able to describe and distinguish between intensive and extensive properties. And by using the density formula, you should not only be able to calculate density, but also mass and volume of an object. So matter is all the physical material of the universe that has both mass and volume, meaning that it has density. Matter can be described and identified by various chemical and physical properties that we're going to talk about right now. Physical properties, these can be measured without changing the identity or chemical composition of a substance, and these are also considered constants about a substance. So if I have a various form of matter, these are going to hold true for that substance. Properties can be observed through physical changes, so whether we look at a phase change or other type of change that we'll talk about in concept D. So examples of physical properties, these can include melting and freezing points, boiling point, conductivity of not just electricity but also heat, solubility, how well it dissolves in a specific type of liquid, and then some other ones such as color, texture, odor, and appearance, and many more. Chemical properties, unlike physical properties, actually do change the identity and composition of the substance. These basically are focused on substances that how they react with other substances, so those behaviors that they're going to go through. So these properties can actually only be observed through the actual chemical change. So we might talk about a substance's flammability or how reactive it is with water and acid or oxygen. These are all various types of chemical properties which we can then observe through a chemical change. Alright, extensive intensive properties. Extensive properties is a property that depends on the amount of material you are dealing with. So mass, volume, and length. So these are properties that we can measure, observe, but it will fluctuate or change depending on how much material we have. So in this picture you can see you have a handful of salt versus a massive pile of sodium chloride salt. So these can change. So let's go and look at mass and volume just a little bit more. Mass is the amount of matter an object has. This doesn't depend on gravity like weight does. So it's not going to change from one location to another because of the fact that it's about that amount of matter that it has. So be very careful, try not to interchange weight and mass together because they aren't the same. We're going to focus always this year on mass and measuring mass. Now volume is the amount of space, three-dimensional space, that an object or material will occupy. And we've already done some of these techniques in our lab so far this year. For liquids we want to use a graduated cylinder. Sometimes towards the end of the year we'll use a burette. Regular shaped objects we can measure the various dimensions, such as for a cube, length, width, times height. We've also done a cylinder already, so using that formula as well. We can also measure irregular shaped objects by using the water displacement method and figuring out the amount of volume of the water that was displaced and equating that to the volume of the object. Alright, an intensive property does not depend on how much of the material we have present. So no matter the size of the sample, these properties remain the same for any of the sample sizes. These properties really help us identify matter and are a constant about that particular type of matter. So intensive properties, the big one is density that we'll talk about, but also melting point, boiling point, solubility, hardness, color. These are all intensive properties. So for example, I have two samples of water, A and B. As you can see that they have different masses and volumes, so those are your extensive properties, but their densities, melting points, and boiling points hold true whether I have 20 grams versus 150 grams. Alright, so let's talk a little bit more about density. Density is the amount of mass in a given volume. It's that ratio of mass to volume. We can also talk about the density in terms of the particles because this measures the compactness of a substance. So an object with a really large mass, so amount of matter, and a really small amount of space or volume has a large density because we compacted a large amount of particles into that amount of space. So here you can kind of see, looking at the particles and seeing how they're packed in can help us observe density. So just a couple of misconceptions for students to be aware of. You don't need to write every single word down into your notes. You can just summarize it for yourself. But a common misconception is just the assumption that if an object is heavy, it's very dense. Or if an object is light, then it's not going to be dense, which is not true. And we I'll give you some examples that you can see in class. But density is more related to how closely packed the mass is distributed over an object. So an object can have a high mass, but if it's spread over a large area, its density can be relatively low. So we have to not just look at mass, but also the volume, the amount of space that mass is distributed over. Another common misconception is that heavy objects sink and light objects float. Now, sinking and floating are related to density and not mass. So also, we need to think of basically that the fluid or solid is less dense than the liquid it's placed in, then it will float. So it's how they relate to each other, depending on the object and then the liquid that we're putting it into. Alright, so solving density problems. Density is going to be mass divided by volume. So again, that ratio of mass to volume. And we're going to go through an example. So here we have the density of a substance is 8 grams per centimeters cubed. What is the volume of a sample of this substance if its mass is 24 grams? So we're given density and we're given mass, so we're looking for volume. I want you guys to write the formula. So density is equal to mass divided by volume, and then you're going to rearrange it to solve for volume. So volume is probably the trickiest ones for students. So I would cross multiply, get dV is equal to m, and then have to divide each side by d, so I have volume by itself. I then input the two given values, and then I go ahead and solve for it, rounding to the correct number of significant figures, which is 2. So this volume would be equal to 3 centimeters cubed. Alright, so here's some practice. This would be a good part for you to pause the video and then try out the next 2 problems, which will basically sum up what we just went through in the notes. Alright, so the mass of a copper wire is 255 grams. I can have copper wire and have it have a variety of masses, so this is something that can change. So it's an extensive physical property. Sodium bicarbonate reacting with acetic acid to make carbon dioxide gas. We're producing something new. We're changing the chemical composition, so this is a chemical property. And then the density of mercury is 13.6 grams per milliliters. This is something that's going to hold true no matter how much of my sample of mercury there is. So this is an intensive physical property. Alright, here was a practice problem that you did for density, solving for mass. So you should have had this work on your paper. Density is equal to mass divided by volume. Rearranging that and cross-multiplying, I get mass is equal to density times volume. I inputted the results, and then I got my answer as 204, and really based on my sig figs for density, this really should have simply been rounded to 200 grams with the tens place having a line over it to show significance, so that I would match up with my 2 significant figures. Alright, well, we're going to practice this more in class. We're going to look at, again, chemical and physical properties and also go more in depth with density and give you some more practice with that. So you are all set.